Every time you turn on a light, send a message, or start an electric vehicle, you are interacting with one of the most powerful forces in nature. An invisible field that surrounds every wire, every magnet, and every electronic device on Earth. It moves trains without wheels, it sends energy across continents, and it may soon power our homes without a single cable. This force is electromagnetism, a phenomenon that quietly drives nearly all modern technology. I'm Binglet Wags, and today we explore the power of electromagnetism and the future it may unlock. For centuries, electricity and magnetism were believed to be separate phenomena. But in the early 19th century, scientists discovered that they were actually two aspects of the same fundamental force. In 1831, physicist Michael Faraday demonstrated electromagnetic induction, the principle that moving magnetic fields can generate electric currents. This discovery became the foundation of electric generators, transformers, and modern power grids. Later, in 1865, physicist James Clerk Maxwell unified electricity and magnetism through a set of mathematical equations that revealed something extraordinary. Electromagnetic fields could travel through space as waves. These waves include radio signals, microwaves, visible light, and X-rays. In other words, light itself is an electromagnetic phenomenon. From radio communications to wireless networks, modern civilization runs on this invisible spectrum. One of the most important applications of electromagnetism is the electric motor. Instead of burning fuel like traditional engines, electric motors convert electricity into motion using magnetic fields. Inside the motor, electric current flows through coils, generating rotating magnetic forces that spin a shaft. This simple principle powers everything from household appliances to electric vehicles. Unlike combustion engines, electric motors are extremely efficient. They transform energy into motion with far fewer losses. This is one reason why electromagnetism is now at the center of the global transition toward cleaner transportation. Instead of burning fuel, modern vehicles increasingly rely on managing electrons and magnetic fields. Perhaps the most dramatic demonstration of electromagnetism is magnetic levitation. Maglev trains float above their tracks using powerful magnetic fields. Without physical contact, friction is nearly eliminated. This allows trains to reach extraordinary speeds. One example is the L0 series maglev developed in Japan, which has reached a world record speed of 603 km per hour. These systems rely on superconducting magnets, materials that conduct electricity with zero resistance when cooled to extremely low temperatures. Because the electrical current flows without energy loss, these magnets can generate incredibly powerful magnetic fields. A key phenomenon behind this technology is the Meissner effect, where superconductors repel magnetic fields and create stable levitation. The result is a transportation system capable of traveling faster than conventional trains while producing far less mechanical wear. Countries like China and Japan are already developing next-generation magnetic transportation systems capable of approaching 1,000 km per hour. While electromagnetism already powers our devices, the next step may eliminate cables entirely. Researchers are developing systems known as wireless power transfer, or WPT. These technologies use resonant magnetic fields to transmit energy through the air. Imagine entering a room where your phone, laptop, and headphones begin charging automatically. No cables, no outlets, just energy moving invisibly through space. Engineers are also experimenting with dynamic charging roads, where electromagnetic coils embedded in the pavement can power electric vehicles while they drive. In the long term, some scientists are even exploring the concept of space-based solar power. Massive satellites equipped with solar panels could collect energy in orbit and transmit it back to Earth using microwave beams. If successful, this technology could provide a nearly continuous source of renewable power. modern electronics rely on moving electrons through circuits. But this process generates heat and limits how powerful computers can become. Researchers are now exploring an alternative approach known as magnetic computing. Instead of moving electrons, these systems use waves of magnetism, called magnons, to transmit information. Because magnons carry energy without the same electrical resistance, they could enable processors that are significantly faster and more energy efficient. Electromagnetism also plays a critical role in the development of quantum computing. Quantum processors often rely on superconducting circuits and extremely precise magnetic fields to manipulate quantum states. If these systems reach their full potential, they could solve problems far beyond the capabilities of today's most powerful supercomputers. The influence of electromagnetism extends even into the human body. Doctors already use electromagnetic technologies for imaging techniques such as magnetic resonance imaging, which allows physicians to visualize internal structures without surgery. But future medical applications may go much further. Researchers are developing magnetic nanoparticles, tiny particles that can be guided through the bloodstream using external magnetic fields. These particles could deliver drugs directly to tumors, targeting diseased cells while leaving healthy tissue untouched. Other technologies include ultrasensitive electromagnetic sensors capable of detecting tiny signals produced by the brain or heart. Such systems could enable earlier diagnosis of neurological disorders and cardiovascular diseases. In the future, electromagnetism may allow doctors to interact with the body at microscopic scales without invasive procedures. For centuries, humans used fire and combustion as the primary source of power. But today, a new technological era is emerging. An era built not on burning fuel, but on controlling electrons, magnetic fields, and electromagnetic waves. From levitating trains to wireless energy network, from quantum computers to precision medicine, electromagnetism is evolving from a simple physical phenomenon into a powerful technological platform. One capable of transforming transportation, medicine, computing, and global energy systems. Electromagnetism surrounds us constantly, yet we rarely notice it. It powers our devices, it connects our communications, it drives the machines that shape modern life. And as our ability to control electromagnetic forces improves, its impact will only continue to grow. The future of technology may not be defined by louder engines or larger machines, but by our ability to manipulate the invisible forces that already exist all around us. Thank you for exploring the power of electromagnetism with me. If you enjoyed this deep dive into science and technology, consider subscribing for more explorations into the forces shaping our world. I'm Binglet Wags, and I'll see you in the next one.